Hi, this here is very common power supply for Commodore 64 machines, and today I would like to show you a method that I use to improve these little things. So, as you probably already know, these power supplies get really hot, and they do have problems with 5-volt rail. And as you know, we have two rails coming out of these supplies. So one is a 9-volt AC, and that one is just fine. The problem is this one, 5 volts DC rail. Now this rail has, if it fails, it has tendency to go in over voltage, and this is of course the problem, because this is a very common way to fry your Commodore 64 machine. So today I will show you a cheap and easy way to make this a bit more safer to use and a lot more colder to run, because these things get really hot. Of course, this is not the best way to do it. If you have a chance and buy a modern replacement power supply for your Commodore 64, please do that. For rest of us, this will be just fine for now. So place it like this, and the first thing that we need to do is remove this bottom lid. Of course, please disconnect these cables from the mains and from your Commodore 64, just in case. Place it right here. So to remove this lid, because it's glued in, we need to probe, and to do this, it would be the best way to do it is to use plastic pry tools, but I don't have that. I will use a screwdriver with smooth head, so I will gently try to see, it's cracking, and oh, it's cracking nicely. So we are going over and over and lifting up. Yes, here we go. Oh, it's cracking. Ooh, this one was easy. Oops. Go here and a little bit here. And a little bit here, of course. Here we go. So here we are inside. So this side here is our transformer. As you can see, it's potted in epoxy and there is nothing we can do here. This is the main fuse, and this PCB here is where is our voltage regulator located, and this is where the 5 volts is produced. So the idea here is to remove this PCB completely and replace it with one of these. Now this is AC to DC converter. The input is the main voltage, so that's 220 volts, and output is 5 volts on 2 amps, so that is perfect for our application. And dimensions fit perfectly inside this little chamber, inside this case, once we remove this PCB. This transformer has two secondary coils. So these coils generate 9 volts AC that goes directly to our Commodore 64, and second coil generates around 13 volts AC that goes here on this PCB, and through this voltage regulator it generates 5 volts. So because we are going to use this one, and this is a AC to DC converter, so that means that we are going to use the mains voltage, main line, and generate 5 volts. We don't need this second coil on secondary side. So what I will do is simply cut this line and isolate them, and we will not use them at all. So we are only going to use the coil to produce 9 volts AC, and because of that this transformer will run much cooler. And this little converters doesn't heat up at all, so it will run cool as well. So that means that we are going to reduce the temperature of this thing dramatically. So let me fire the soldering station and try to remove this. So the only way that we can remove this PCB is desolder all these connections here. Okay, so for this linear voltage regulator that is potted in epoxy, we cannot do anything. We will left it inside, and what we are going to do is just cut these legs nice and disconnect it. Now these two lines here are our 5 volts rails, and what we need to do next is connect this AC to DC converter, and as you can see it fits just inside nicely. Very nice. So what we have to do next is we have one connection to the mains disposed here, so we can solder in here at this point, and this point is behind the fuse, so we will be protected. The problem is this side here. So as you can see, this mains are, this side is completely potted in this epoxy, so we will need to probe in somehow and get to the metal connection. So I will try to do that next. So it has been a couple of days until I had my brilliant idea that I'm going to break this part and expose this leads, this connection for the transformer. So everything here went from bad to worse to terrible. So as you can see, our transformer is out of the plastic case, and that was not the intention of this project. So the whole idea was to show you how to do this without actually removing this whole potted transformer out of the dead box, because that is sometimes almost impossible mission. As you can see here, I needed to use quite a lot of brute force to get it out, and the case is currently A, damaged, B, maybe we can fix it, and C, currently retrobrating. So we will see about that. Also, this, if you remember, here was the little blue wire that was exposed. It was not potted. All I need to do is just to remove a little bit of insulation from that wire and solder directly to it, but unfortunately that never actually crossed my mind. So this crossed my mind, and this was a terrible idea. Luckily I tested it, and transformer still works and still produces 9 volts AC. So that means that we are currently good to go. So at this point we can continue with this project. So our AC to DC converter is here. We have some wires that we are going to connect all this, And so, like I said, to connect to the mains, we are going to use this connection here, which is after this fuse, which is good, and we are going to use this connection here. That's the second phase of the mains. So, and we are going to solder on these two connections here, and then we will have our plus 5 volts output here, and then we are going to connect these two wires. So let me fire the soldering station and let's continue with this build. Nice. And this. Very nice. Okay, this is it. Now we need to figure out which one is plus 5 and which one is 0 volts. Which one is ground, which one is plus 5. Let us see. I could check that at the beginning, but I didn't. Yeah, that's luck. Okay, so where are we? Okay. we need to see which one is here. Okay, like so. And then I believe this one is ground. Let me check that one moment. So let me do this. So I selected this green wire there, and the ground should be. Let me switch to. Okay. Yes, this is the ground. So this should be plus 5 volts. Not connect to this. Yes. So this is the ground. And the ground is this one. Okay. Okay, unfortunately my camera didn't record everything that I made here. So what you haven't seen is isolating every connection here and using the nail polish to cover every open contact that I could see in this area. And the only thing that is left to do now is to power this on, of course, and see do we have correct voltages. Yes, and just one more thing, what you didn't see, here is the case. This is the bottom part, and unfortunately this is the upper part, which is completely broken on each side, but I think I can save this, and I will probably use it for the moment until I find something more suitable. Make something like this. I don't know, do you see here? Let me. Yes. Okay. So. Okay. And we are plugged in. There is no smoke. Everything looks good. Now, let's carefully try to measure voltages. And 5 5.9, 510. Okay, and this here ten 10.4 volts. Okay, this looks pretty good. I'm happy with this. Let me unplug it, and then I will put everything inside the case. Well, it will serve the purpose for the moment. Yes. Okay, here we go. Yeah, it's stuck. Of course it is. Is this the correct way in? Yes. Ah, okay. You're in. Oh, this something is not completely right. Okay, now it fitted nicely. Now, let me see how this was like this. Yes, okay. Now what we are going to do is just put this here and put these right here, like so. And just let me check where do we... Okay, there's nothing. Okay, here we go. This is it. Like I said, this case is a little bit deformed, but for now it will be okay. And the only thing that is left to do is power some C64 with it. Okay, moment of truth. Let me switch on the power supply. This LED is not connected, so it won't light up. Here we go. And here we are in basic. Now let me switch a little bit whiter. And yeah, we are working. So yes, here we go, running nice and cool. And as I mentioned, this is very good option for this transformer because it currently runs only with one coil that is 9 volts AC, and it's running very cool. The 5 volts DC is of course generated by AC to DC converter. And the only thing that I actually need to do is find myself a new case for this power supply, and probably I will go with some modern enclosures. There you go, this is it. This is the whole project. Thank you for watching and goodbye.